Question 16. TA and TB are tangents to a circle center O. Show that triangle OAT and triangle OBT are congruent. Give a reason for each statement you make. Now, to prove that they are congruent, let's revise the 4 tests of congruency tests. So usually we'll list out the congruency test and we will see which one to eliminate and the final one that we use out of the 4. So the 4 congruency tests, number 1 will be SSS test, side. Number 2 will be side angle side. Number 3, it will be angle side. And number 4, it will be right angle hypotenuse side. So if you look at this question, right, the one that we are most likely to use, okay, I would actually think of this first. Okay, reason being because we have a tangent and we have the radius, we already know there's a right angle. And anything with related to the right angle, I will think of the 4th test, right? Okay, so the very first thing, actually I know this is the right angle and this is the right angle because this is the radius and this is the tangent. So let me begin with the very first statement, which is angle TAO is equals to angle TBO is equals to 90 degree, and this property is tangent perpendicular to the radius. Now take note, when you label the names, it must strictly come from the letters here. Okay, so let's say this angle I have to label as TAO. I have to use O. I cannot use like TA something else. Okay, but anyway, this one, there is no other alphabet you can use other than TAO. Sometimes in the diagram they can give you, it can be a little bit tricky, they can give you a C here. And labeling TAC, you might think is the same as labeling TAO. Okay, but for congruency test, strictly you have to use back the alphabets they gave you. Okay, so this will be okay, and also this one as well. So we already have one right angle, right? Okay, so now let's take a look at their hypotenuse. So can you see if the right angle is here, their hypotenuse will be the one that is opposite, right? Their hypotenuse is actually this one. And you will realize that they actually share the same hypotenuse. Can you see? They share the same hypotenuse. So we can say that, okay, OT is a common, okay, side, actually, in fact, okay, common hypotenuse, okay? So we fulfill the H as well, and we need one last side. Okay, actually pretty easy. You can say the radius is the same, or you can say the length is the same, okay? If you use this equals to this, then the reasoning you should be using is tangents from external point. Okay, if you're using this, then it's very easy, just radius of circle. Okay, so we already got the very first one, okay, which is the R, second one, which is the H, and the third one, okay, now we go to the side. Okay, as mentioned, you can use either two. So the very first one, I will use OA. Do take note, if you use OA, make sure you have to use OB, okay? It cannot be BO, it cannot be switched around. So we will use OB, and this is because they are the radius of circle. Okay? Okay, to make it even more precise, I will say the radii of circle are equal. Radii is the plural form of radius, right? Because we have 2 of them, so I'll change it to radii. Radii of the circle are equal. Okay? Okay, you can use this, or the last one, you can also use the fact that AT, okay, I'm going to use this AT, then I have to use BT, okay? AT equals to BT, this is due to, okay, this is due to tangent from external point, okay? You can put EXT, or you can write out the full form, also no problem, from external point. Okay, so there you go, okay, RHS. Okay, so in this case, okay, we have given the reason for every statement already. And lastly, we will now say that angle OAT is congruent. We can use these 3 lines to represent congruency, okay? Triangle OBT, and this is due to RHS test. Okay, so done. For part B, we need to mark out point P which lies on the circumference of the circle such that the triangle APT is congruent to triangle BPT. On the diagram, mark the 2 possible positions for point P. Now, do take note that, okay, AT comes from here and BT comes from here. So as you can tell, AT and BT are already equal in length due to the fact that they are tangents from external point. So to mark out P such that it will be equal distance, okay, it will form equal distance from A to B, is actually we make use of the radius. Can you see the radius AO here is equals to the same as BO here? So if we get another radius, okay, we can form the congruent triangle. So I would suggest that you use this next radius here, which also means that you can mark out your point P here. Alright, and this is how you form the triangle. Alright, this triangle will be equals to this triangle. Okay, because this is the radius, so they have the same side. Alright, and then this, we already know this length and this length is the same due to the fact that they are tangents from external point, and the last one, they have equal length for the common side, right? And then another way to get the next point P is you use the radius, same radius, but you extend it to the other side. So here is your another point P. The reason why when we put point P here and it will still work to get the two congruent triangles is because, as you can see, okay, the first triangle, which is your APT, as well as second triangle BPT, okay, number one, they share a common side. Okay, so you have one side already. Number two, they also share another side of the equal length because due to tangents from external point earlier on, so you got another side as well. Okay, so you got S and you got S. Last but not least, you also got the same angle right here, which is also come from the tangent from external point. So you actually have two sides. Okay, two sides and one included angle. So by SAS test, right, okay, putting point P right here, it will make the two triangles congruent.